Okay, so in this video, let's talk about like the fundamental theorem of calculus. So basically, let's say like maybe you have this function here. Let's say maybe you have a function with respect to t integrated with respect to t, and you have the boundaries, and one of the boundaries they technically include a function of x, and you want to derive that with respect to x. So what actually happens? So this is not a big deal if you look at it. All we know is that if you're integrating a small function f of x dx, this is technically going to give us like a capital F of x there. And then that's just what we know, that the integral of this is technically that. So another thing we know is that if we take this from a to b, if we take this from a to b f of x dx, this is technically going to give us like capital F at b, and then subtract that at a. So this is what we know. Okay, so let's look at a function f of t there. So what do we have there? So if we say d over dx of remember this one will just be some constant there, and the upper boundary there we have a function of x there, and maybe let's say for simplicity reasons let's say it's g of x, and you're integrating f of t with respect to t. What we know about this is that this is technically the same as you're saying d over dx of capital F at g at x minus capital F at a. And now here you just have to take the derivative of that. You just have to take the derivative of that. So we're just going to have d over dx of that. But since we have a function there, then it's just going to be a composition. Then we apply the chain rule. So we have g prime of x multiplied by the derivative of f prime evaluated at g at x. And what's the derivative of f prime? Notice that here, if you take the derivative of that, you know this, that the answer when you integrate will basically take you back to that. So since we had f at t there, plugged in our boundaries there, so this technically means that we're just gonna have this being small f, this function there. So that's just gonna be g prime of x multiplied by f evaluated at g at x. And now since f at a is some constant, then that derivative will basically be 0. So then you just end up having something like this. So that's just the derivative of that. That's the fundamental theorem of calculus. So d over dx of 0 to x squared of the square root of 1 minus t to the fourth dt, this will just be equals to, you plug in x squared where there is t, then you just have the square root of 1 minus x squared to the fourth, that's 2 by 4, that will be x8, and then you just derive x squared there, and then you're just gonna have 2x there. So that's how it's done. So you can do this for all functions really. So if you have d over dx of the integral from the square root of x to 1 of let's say 1 over 1 plus t to the fourth dt, so this is the same as d over dx of negative the integral from this to that. So you just switch the boundaries and put in a negative there. Then you have 1 over 1 plus t to the fourth dt, and then that means that you just plug in the square root of x where you see t, and you multiply by the derivative of the root x there. So you basically just apply this formula that I just derived for you. So then from then that means that the derivative of the square root of x is 1 over 2 root x. Don't forget that you have this negative there, so just put it in front, it's still fine. Then you plug in root x there, so root x to the fourth, that will be x squared. So that means you're just gonna have 1 plus x squared like this. So you can further like rewrite as 1 over 2 root x into 1 plus x squared, and then you're just gonna have that negative there. So that's how it's done. Okay, so let's say maybe like you have a function from x to the x squared of 1 over 1 plus x squared, let's say t squared dt, and then you just have d over dx of that. Remember, you can rewrite this integral as d over dx of the integral from, let's say, some constant c to x squared of 1 over 1 plus t squared dt. And then it depends whether you want to put in a plus or a minus, but I want that x, this x here, to be on top there, and then you have c there, and then you have 1 over 1 plus t squared. Since this one comes with a negative c there, then that means you just put in a negative there. So this lower boundaries will cancel out, then you have something like that. Then you just apply the fundamental theorem of calculus there on each integral. You can rewrite it as something like this. So you know what must be done here. You derivate each individual integral there. The derivative of x squared there will give you 2x, and then you just plug x squared there. So you're just going to end up with 1 over 1 plus x to the fourth. minus the derivative of x is just 1, so 1 multiplied by any number is basically that number. So then you plug in x there, and then you're just going to have 1 over 1 plus x squared. So